A solution is prepared by dissolving 0.3579 grams oxalic acid in enough water to make 50 ml of solution. A 2.5 ml aliquot of this solution is then diluted to a final volume of 100 ml. What is the final molarity of the diluted oxalic acid solution? From the first sentence of the question, you can actually solve for the initial concentration of oxalic acid. So we know that the formula for molarity is moles per liter. And we know that moles is computed as mass over molar mass. So if we compute the initial concentration of oxalic acid, that would be the mass of oxalic acid, 0.3579 grams, divided by the molar mass of oxalic acid, that is 90.036 grams per mole, divided by the liters of solution. So you need to convert 50 ml to liters by dividing it by 1,000. So 50 divided by 1,000 is 0.05000 liters. So grams would cancel, and we are left with moles per liter. So the initial concentration of oxalic acid is equal to 0.07950 moles per liter, or 0.07950 molar. The next part of the question is dilution. So for dilution, the formula is C1V1 is equal to C2V2. So C1 is the initial concentration, V1 is the initial volume, C2 is the final concentration, and V2 is the final volume. So the problem wants us to solve for the final concentration or the final molarity. So we need to rearrange the equation to solve for C2. So you divide both sides by V2. V2 would cancel on the right side. So the formula for C2 is C1V1 over V2. So we can now solve for C2. It is equal to the initial concentration C1, which we just solved earlier, 0.07950 molar, times V1, which is the volume of the aliquot. You have 2.500 ml. So we put 2.500 ml divided by the total volume, V2. The problem says the final volume is 100.0 ml. So 100.0 ml. So ml would cancel. The unit would be molar. So if we solve for C2, it is equal to 0.001988 molar. So this is the answer to the question.